Hello, welcome back to Math 152. This video lecture is going to be covering section 2.2, frequency distributions and their graphs. So our objectives: construct frequency distributions for quantitative data this time. Last time was qualitative data. Construct histograms, determine the shape of a distribution from a histogram. So frequency distribution for quantitative data. We're going to have to treat these a little differently than we did qualitative data last time. Qualitative were just categories, remember, red, blue, green, yellow, and then we counted up the frequency of how many people chose each category. For quantitative data, we're dealing with numbers, and we have to deal with two different types. They could be discrete, or we're going to find out that they could be continuous. Discrete data is just basically the integers 1, 2, 3, 4, 5, and then other times we're going to have where they could be any range of data between like 0 to 1, 0.1, 0.11, 0.25. So we have to create our frequency distribution in a little different ways. So if we have a wide width of data, so that it goes from, like, let's say from 1 to 1,000, we want to basically bring that in together and be able to look at it in terms of a table, how many times a certain, not a certain number in this case, but a range of numbers occurred. So we're going to call that the class. So to summarize, quantitative data, we use a frequency distribution, just like those for qualitative data we did last time. However, since these data have no natural categories, we divide the data into classes. So we lump them into different classes. Classes are intervals of equal width that cover all values that are observed in the data set. The lower class limit of a class is the smallest value that can appear in that class. The upper class limit of a class is the largest value that can appear in that class. So over here, we see each one of these are called a class, each row. This class, the lower limit is 0, the upper is 4, and it says there were two numbers, two data values that were between 0 and 4 inclusive of these two. So it could have been a 0 and it could have been a 4. The class width is the difference between consecutive lower class limits. So it is not 4 minus 0, 4. This one is 5 minus 0, or 5. So the class width goes from 0, I add 5 to it. 5 plus 5 is 10, plus 5 is 15. And it works similar to here. 4 plus 5 gives me the 9. 9 plus 5 is 14. 14 plus 5 is the 19. So setting this up is really dependent on what our requirements are for that problem. There are many ways to construct them. They will differ depending on the classes chosen. And here's some guidelines for choosing classes in the slides. Every observation must fall into one of the classes. You want everything covered. The classes must not overlap. The classes must be of equal width, and there must be no gaps between classes, even if there are no observations in a class. It must be included in the frequency distribution. So 0 should be 0. Everything's in there. Okay. So here's our steps. We're going to choose a class width, or given a class width. Choose a lower class limit for the first class. This should be a convenient number that is slightly less than the minimum data value. Compute the lower limit for the second class by adding class width to the lower limit for the first class. Lower limit for the second class, just add the class width and continue on, and then start working on the uppers. Count the number of observations in each class, and then construct the frequency distribution. So here are the emissions for 65 vehicles, and units of grams of particles per gallon fuel are given. Construct a frequency distribution using a class width of 1. So we would take our data, I'm going to show you this in a minute, we'd put it into Excel. We'd start generating our frequency distribution. The lowest value for this one is 0.25, and to make it into a nice class, we choose 0 as the lower limit for the first class. You might want it as 0.25, but that's okay. We're just going to start at 0 for this. class width is 1, and the first lower class limit is 0, 0. So the lower limit for the second class is 0 plus 1. We're going to back off for the upper class from that thing to whatever decimal place that we would need. We're going to 100th digits, so we would go to 0.99 for that first upper. So here are all the remaining lower class limits. We just continue to add 1. And then we back off, so when we state those class limits, the 0.00 to 0.99, we went to 1 for the next one. We were going to 100th digits on those values, so we subtract off 0.01. That gives us the 0.99, and that'll give us all the data between those, and we just count them up. Okay. We can do relative frequencies just like we did in categorical data, qualitative data, same thing. Given a frequency distribution, a relative frequency distribution can be constructed by computing the relative frequency for each class. So I sum up all the frequencies, and then for each individual frequency, I divide it by that sum to give me the relative frequency. So when we go through a check, we should have all of the data, the frequency of our data, we add those up, and then adding up the relative frequencies, that should add up to 1. And then we'll basically go through and build a bar chart. In this case, we're going to call it a histogram. Once we have a frequency distribution or a relative frequency distribution, we can put the information in graphical form by constructing a histogram. A histogram is constructed by drawing a rectangle for each class. So this is a class width now instead of just a bar chart for an individual item. The heights of the rectangles are equal to the frequencies or the relative frequencies, and the widths are equal to the class width. So here they've generated this, the histogram for you. Here's the bars between the particulate emissions with the frequency, and here's the relative frequency histogram. Notice that they look the very same. They're the same percentages, and we just construct it out. So I'm going to switch out of this. I'm going to go to Excel. We're going to build that. So I've copied the data. Here's our data values over here in column 1 all the way down. And then I started out just like they did. Here's our lower limit of 0. Here's our 1. And when I started this, I said, now let me let Excel finish this out for me. So I did this as a formula. I said equals, take whatever's in the previous column, previous row, and add 1 to it. And then I did my fill handle all the way down, and it just automatically incremented the previous reference and added 1 to that. And I did the very same thing. I started out with 0.99. I did 1.99. I said, let me let Excel finish it up. Do my drag on my fill handle, and it just automatically added 1 to each one. Now I could go, when I did the frequency, I could go and start counting these things up between this range. And again, I would let Excel do this for me. This is kind of a long formula, but this is how I would do it, because I would want everything between these two numbers. So I'm going to use this function called COUNTIFs. So this gives me several different criteria where I would want to count. I could count into different columns or in different tables. But here all I'm doing is saying the range of data that I'm going to count from is the $A, $2. So always do this. Always look at this one place. Don't increment those. And count them if it's less than or equal to, this is my criteria, the F2, so it's less than or equal to my upper one. And then this COUNTIFs gives me several things. Now go back and go through the same range, and if it's greater than or equal to what's in this E2, so the 0. And then when I do it counts, and when I do my pull down, it automatically increments everything for me to say that's my E3, F3, E4, F4. But notice these absolute references are not changing. They're always going through and looking at the same table. I'm going to take it here. There's 0. If I sum these up, Notice that was the 65. That gives me the full range. And then if I wanted to go and develop a histogram for it, there's a couple of ways that I could do it. I could do it manually. I would go here, I would select, here's my upper, and there's my frequency, and I would just say insert. I would do this as a regular bar chart to do this. Okay, so that would be that, and then I would basically go through. It doesn't give me a nice, here's the 0 to 99. I've also done this as a separate table where I do this range by hand, 0 through 99, to give me this down here at the bottom. I can also let Excel draw this thing for me. So if I just want to go quickly grab some data, here's all my data points. I go to the end. I say insert recommended charts. Now there's all charts down at the histogram. And then it automatically bins everything for me. These are called bins. And it automatically bins our classes. And it automatically puts those things in for me. Now it picks these value ranges that it wants to. It automatically does this. It wanted it in 1, 2, 3, 4, 5, 6 classes. I could change that if I select on this horizontal table. Format the axis. You have to click very close on there. Format the axis. Come on. Format the axis, and then I come over here. Move me out of the way just for a second. Thank you. And here was the automatic for the bins. I can say the bin width. What we did was 1. And it recalculates based on what we had before. There's the 0 to 99. Or I can say number of bins equal to whichever ones I want. But notice this, ours goes from 0 to 99. The only problem is this is going from 0.25 to 1.25 instead of what we had from 0 to 0.99. So the counts are a little differently from what we see. But that's letting Excel do it and then just modifying whether we want number of bins, classes, or the bin width. So how do we choose the number of classes? There are no hard and fast rules for choosing the number of classes in general. It's good to have more classes rather than fewer, but it's also good to have reasonably large frequencies in some of the classes. So you don't want it too fine-grained when you've got a bunch of zeros. Too few classes produce a histogram lacking in details. Too many produce a histogram with too much detail. So all the features of the data are obscured. So you just got big blocks that there's just a bunch of data in there. So you want something that granularity that's good for you. So here's some illustrations of that. The following histograms illustrate too many classes and too few. Here is too many classes. I've got a lot of empty holes in here. But if I broke them up and did too few classes, which makes the class width larger, then I've got all the data in here. Well, these are very fine particles. You know, that's a lot of area in there. Your textbook slides also provide some instructions if you're using the TI-84 Plus, how to create a histogram, enter the data in list L1, press second Y equal, then 1 to access the plot, and then you can zoom 9 to view the plot. Open-ended classes kind of break what we said before, where everything needs to be in a class. We do a class, but it is like 85 and older or something beyond that. So here is the following frequency distribution presents the number of deaths in the U.S. due to pneumonia in a recent year for various age groups. Note that the last age group is 85 and older, which is an open-ended class. the person in here, these are only going class widths of 10. So this one's going 75 to 84, 65 to 74. This one could be anywhere 85 to 95, possibly 105. But that's the open-ended class. That last one does not meet our usual criteria, and it's just kind of get everything else out there. Before we put them into classes, if you have discrete data, we're going to talk about discrete distributions later on. But discrete, we could have just very few numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8. These are only going to count to a certain thing. They're very small numbers. The range is enough that we would want everything. The following table and histogram presents the results of a hypothetical survey in which 1,000 adult women were asked how many children they had. So 435 out of that 1,000 had 0 children, 175 had 1, 2 was 222, 3, 112, and then continues on. None had a greater than 9, or none had 9 or greater. And then we can basically build the histogram from there. So when we build these histograms, the shape kind of gives us an idea of how the data looks. I'll say looks. It gives a visual impression of the shape of a data set. Statisticians have developed terminology to describe some of the commonly observed shapes, and we'll kind of see these throughout the course, and we'll learn a little more of how to identify them and what we're looking at. So here's some shapes these are the common ones that we're going to look for. A histogram is symmetric. We're going to call it symmetric, and there's different symmetric shapes, but we're just going to use that generic term for now. The symmetric, if its right half is a mirror image of its left half. And what I'm saying from the half is that if you look at the peak, that's kind of the center of data, and we'll look at that more in this chapter. To the right, to the left, and if we look right down from that middle, it looks like almost, it doesn't have to be exactly, but it has to be a pretty close shape. Got a nice mountain going up, nice mountain going down. Here's one that doesn't match that, so somewhere, whatever the peak is, this could be the peak, but certainly there's no data to the left and to the right of it. So this could actually have been moved over a little bit so the data goes up, but if it has a long right tail, so here's most of the data is in here, here's the frequency, right? So most of the data was occurring in here, and then it trails off. If it's got that thing, looks like, I call it a mouse, and here's its tail, that's the right tail. We call it skewed to the right or positively skewed. So that matches. The positive, like if you do positive number line with positive numbers, that's to the right. And that's the positively skewed to the right, right tail. A histogram, I think we can see it okay. A histogram with a long left-hand tail is said to be skewed to the left or negatively skewed. These are the side of the negative numbers, more to the left. But here it trails off. That would be the big mouse, and there's these long tails strung out. In some cases, we may be interested in the mode. We'll talk about the mode as well later. If we've got some place where the data occurs again, where there's a peak or high point, this is called the mode, that's a high point. If it only has this one high point, it's called unimodal, one mode. Bimodal, if they have two clearly distinct modes. Now these things were kind of bumped up beside each other. I wouldn't say this one, like if it was up here, it would be bimodal. It was just somewhere in here would be the peak. But here I go up, I'm going down, and then I'm coming back up again like a M. And that would be bimodal. So let's summarize some of the things that we talked about. How to construct a frequency and relative frequency distribution for quantitative data, this time not qualitative. We just basically put them into classes and then we added them up. We could do discrete data 0, 1, 2, 3, 4, 5, and it wouldn't be a class. It just that number would be the discrete data histogram. But again, we would count how many was in that class or that data. So how to construct and interpret them, we went through that. Excel is the best way to do those things. You can do them by hand, certainly, but if the data set is large, it's going to get pretty much unwieldy. The guiding principles for choosing the number of classes in a histogram give us something that we can actually visualize where the data lies, and it's not overly bland. How to construct a histogram on the TI-84 Plus calculator. If you have a TI-84, there's a lot of nice features in there that you could use. Some possible shapes of the data set, including symmetric. Does the left side match the right side? Whatever the center of data is that left and right look mirror imaged. Skewed to the right, right-tailed, positively skewed. Skewed to the left, left-tailed, negatively skewed, just like the number line. Unimodal, there's only one group of data, and it kind of at that one spot. Bimodal, if it's clearly one high point, the data goes down, and then all of a sudden I see another batch of data come in at that range, at that class of ranges. That's the bimodal. So that finishes it up for section 2.2 today. I hope this has been helpful. See you in section 2.3. Have a good day.